Good morning, good afternoon, good evening, and welcome back to INE CCIE Security Troubleshooting Online Bootcamp. Let's do a basic audio video check before we get going. So if any of you can both hear me and see me at the same time, just let me know in the chat window, please. Okay, thanks. Good. So today we're gonna do ASA Firewall Troubleshooting. Before we look at the topologies we're gonna be using, if you look in the share of the class, you can find under the one of the two topologies we're going to be using today. We're going to use two topologies. One of the two topologies we're going to use today is going to be uploaded on the share, and also the initial configuration files. So basically, if you wanna do the same thing I'm doing on my rack, you can rent your own rack from INE's security rack rental system and load the initial configuration files, which are as well attached on in the share. Now, before we go to the ASA troubleshooting examples we're going to do today, let's take a closer look at the. I want to show you some Cisco representations. Going to take a couple of looks in there just to confirm some things which you need to know to get going for the today's class. And either way, as I said in the, I think I said in the configuration class, Cisco representations, depending on the level they are, like for example, the ones with level 3 or 4 are actually in general very good. So the level, the presentation numbers, if it starts with 1 is like basic beginner. If it starts with 2, code number 2 like 2001, it's intermediate. If it starts with 3 like 3000 something, it is advanced. And if it starts with 4 like 4000 something, is going to be basically very advanced. So also for the ASA, there are two presentations I want to take a close look with you for a couple of minutes. So one is the troubleshooting presentation. So it's the session number 3020, right? So it's session number 3020, and let's say, there we go. Okay, so in this session, one of the things I wanted to share up with you is the packet flow in the ASA, which is important to understand to troubleshoot. Basically, let's do a zoom in. And this is of course how it runs nowadays in this codes, because in the previous codes, like before, it used to run a bit differently. So basically you go left to right as the ASA receives the packet. You go left to right, correct? And basically, as you can see, step number 1, it's clearly the ASA tries to look in the connection table to see if there's a connection or not, yes or no. If the connection exists already, then it bypasses any kind of NATs or whatever. It goes to the stateful inspection directly, because basically in the connection table you also find basically the NAT IP addresses of the if NAT happened. So the ASA doesn't need to go for an existing connection to do the unnatting, to call it that way. So that is step number 1, existing connection. Step number 2, which is important to realize, is basically step number 2 is NAT untranslate. So it's basically destination NAT. That's why it's called untranslate. Basically, because in the ASA, as you remember, as we were speaking, accept twice NAT, which allows you to do both source and destination NAT. In general, on the ASA and on the iOS router, basically always did source NAT. So the configuration that was done to do basically source NAT, but depending on how the flow is initiated, the router or the ASA may end up doing destination NAT or source NAT as well. But configuration wise, you always did source NAT, while of course the ASA with the new code 8.3 and above allows you to do both source NAT and destination NAT at the same time. Regardless which method you use, when the ASA does destination NAT, it is called untranslate. And that happens before basically step number 3, which is the ACL action. Okay, so this is for a specific reason. So because in 8.3 code and above, when you build an inbound ACL on the ASA, and in that ACL you're gonna allow or deny traffic which is destination netted. You're gonna be matching on the real address, not on the mapped address. So it's different than how it was in before 8.3 when you had to match in the ACL on the netted address. Now you have to match in the ACL on the real address, not the netted one, and that is for scalability, because basically ideally if you do object net, for example, and in the object to define the real host and then you perform the net function, then in the ACL you can basically call in that object, which is going to basically match in the ACL on the real IP address. So that's way more scalable, because basically when you change the net statement, automatically the ACL is updated as well behind the scenes. So to make this happen, basically what they did is they changed order of operations. So first the ASA does destination net or on net, step number 2, and then it looks in the inbound ACL or global ACL to verify if traffic is allowed or not. And afterwards, basically what you're interested to, after those two steps, which are on net or net, and ACL, which can be inbound, or global, which is global inbound, then we go to stateful inspection, which is basically this is the MPF, partially the MPF, right? We don't have firepower in the lab currently. In the next version is going to be, so no firepower in their module. Then it goes and does not IP header, which is basically this is the source net finally. So there you go, you do the source net in here, and then you find the egress interface, which you know that the egress interface is found number 1 from the net statement. If the net statement is static, or if it's static, and also it doesn't have the any keyword as the interface, as the interface. Otherwise, number 2 from routing. So we have to remember that basically on the ASA, for when the ASA matches a destination net entry statement, the egress interface is identified from the net statement, not by doing a route lookup by default. You can change that with the route lookup function only in codes above 8.3. Before 8.3 couldn't do that on a per routing entry, but after 8.3 you can do that to change your order of operation, so that even if the packet matches a destination net rule on the SA, you still can do first route lookup and then destination and then netting basically. Otherwise, it's first gonna find the egress interface from destination net. It's gonna basically route the packet from the net statement, and then it's gonna do a route lookup only to identify the next stop value and to ARP for it if that was not already done before. Also, basically, if there is no destination net matching for that flow, basically the SA is going to do regular routing, show route, and it's going to identify the exit interface from the routing table, not from the net table. Okay. So when it reaches the stop layer 3 route, it depends. It can be one of the two cases. One, if the egress interface was basically identified from a net statement, then here I do a layer 3 route only for the next stop to identify what is the next stop value. And the next stop is to be routable out on the interface where the packet was exiting the ASA from the net statement. Otherwise, step number 2, if the ASA didn't route the packet based on destination net statement, otherwise number 2 is going to do a route lookup to identify basically the route. So how do I route for the destination basically? So in case the exit interface was not identified from the net statement, basically the ASA is going to do a route lookup to identify how do I reach the destination, because it doesn't know how to reach the destination on which of its interfaces to begin with. And I would state pretty much this would be it important from this presentation. You can visualize, you can read more of this in the of course clearly for yourself. We don't have to do this in class. So it's a good presentation. We're going to do other things in class, not what's in this presentation, but it's a good reference point to know your way around, like a checkup, a sane check, to make sure you're on the same page with exactly how it works and what would be the steps to troubleshoot specific setups if the case shows up. So this is the troubleshooting firewalls presentation from Cisco Live. It's code number 3020, and there is one more, which I'm not gonna get into any details. I'm just gonna present it to you so you can as well go to it back home not in the class, is basically the firewall core for CCIE candidates. So it's kind of like, it's not exactly only for CCIE lab exam, it's in general for CCIE candidates. So it's another 3000 level presentation, 3203, and basically it's gonna again walk you through different kind of configurations on the ASA, and basically specific problems you may get into. And I of course I had not attended the presentation, but based on these diagrams, it looks like something like this you might get in the CCIE lab exam. So it could be like a preparation behind the scenes for some examples you could get in the CCIE security lab exam, the current version. So ideally it would be a good thing to just go through it and see if there's something interesting or something that you didn't know before. So it's a good overview to look after for. Let me see if I find, for example, a example from here, like let's speak about, let's see if they find CCIE security example, right? So there you go. You're gonna be given some examples. Okay, exactly, not something which you're gonna get in the lab exam, but something similar clearly. And you're going to give it like a big diagram with whatever is configured in there: fragmentation, BGP, normalizer, TCP normalizer. It's active, it's active standby in there, the configuration. And basically you have to make sure that traffic goes correctly between the server on the left side in here, this is the source, probably the session, and somebody on the internet, which is the destination. So destination is in there. And basically after the diagram is presented, you're going to be given with example configuration to make that work, like make the BGP session work. It's not clearly explained, of course, so it is not explained in details. But if you want to also hear the presenter speaking, which is going to make a lot more sense. So for this kind of presentation, the presentation by itself doesn't make always a lot more sense. So ideally you should also watch the video session if available. And both of these, also the presentation, the PDF file and the video session, are available like free of charge. You just need an account on Cisco Live, and then you can download those and look at those. It's free of charge basically. Okay. Now let's get back to what we're gonna do today, which basically, looking at the diagram, we have like EIGRP running in here. So between router 1, router 2, and ASA 1, we have EIGRP 111 running. Then we have between ASA 1 and ASA 2, we have RIP running. So RIP. And then between ASA 2 and router 4, we have OSPF running. So here we run OSPF. Both of the ASAs are running in routed mode single context. ASA 1 runs code 8.2, so the old net, and ASA 2 that runs code 8.4, so basically the new net, 8.4 and 8.2 on these two ASAs. And basically the scope of it is we're gonna have to provide connectivity between different IP addresses, mainly on the routers. So all routers, router 1, 2, and 4, router 1, router 2, and router 4, are going to have a lot of loopbacks in the format. For example, loopback 0 is going to be 150.1.x.x, where x is the router number, so that 1 on router 1, 2 on router 2. Loopback 1 is going to be 150.1.xx.xx. We're going to have loopback 2 in the format of, for example, x, 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 and loopback 3 in the format of xx, 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 all of them being basically /32s. Not that it would matter. And basically we're going to have to provide a lot of connectivity between those loopbacks somehow. It's going to speak in a couple, so we're going to have different tissue tickets, and we're going to speak about how would you investigate a problem, where you start from, but most importantly, what is the strategy you're gonna take, and because that's very important. So as I was saying yesterday, for the T-shooting, you need two things to master very well. Number one, to master the technology inside out. So you gotta know inside out how it works, what are the steps to make it work, what are the commands to make it work, what are the verification commands to verify exactly each of those steps. So that is a must in order to be able to troubleshoot something. So you gotta know what to expect on a show command if the technology works in a proper way, or in option number one or option number two. So depending how you configure those around, you gotta know what to expect on the show commands, and then what to do next, how to fix the problem. And then the second step is to how to troubleshoot, which we're gonna do extensively this week. Basically, you don't go on the ASA on the command line and just stop dropping commands in there, like show commands or debug commands or whatever. As I was saying yesterday, debugs, we don't have time for those in the lab. We're gonna do some debugs today because we need to learn how things work. But in the lab exam, you don't have time for debugs. Just like the gate, that's like the gate of last resort. In case you have a lot of time and you have a tissue ticket which you have not been able to fix, then you may get to debug commands, but otherwise no time for that in the CCIE lab exam. So basically, as I was saying, the next step would be to basically, except knowing everything how it works inside out, the next thing would be to be able to look at the diagram and logically draw like the packet flow through the devices involved within the source and destination, and with knowing exactly what's configured on those devices, or if you are pre-configured, by quickly identifying what's configured in there to quickly be able to identify what the problem is. And within that process, basically, you gotta make sure that, as I was saying yesterday, you don't jump between like let's say the steps of troubleshooting, because as you're gonna see even today, with whatever we're gonna do, like for example, if let's say I don't know, telnet doesn't work between router 1 and router 4, let's assume that, okay, so telnet doesn't work, you're gonna be given some kind of information, right, and to how telnet needs to work. But of course, step number one, you're gonna make sure that routing works. So you have the routes to begin with, you gotta make sure that 1 and 4 can reach their loopbacks to begin with, right? That has to work to begin with. Step number two, you gotta know how is this ASA configured, like ACLs, NATs, security levels, this ASA as well, because those things will influence the packet flow if it's gonna be allowed or not. So basically, you gotta know on ASA 1 and ASA 2, ASA 1 and ASA 2, you gotta basically quickly identify everything which could affect that packet flow, which is gonna be things like ACL, security levels, NAT, MPF, let's say most commonly, so ACL, security levels, NAT, MPF, or I would say pretty much those are the important ones. And then step number 3, if that's okay, then step number 3, let me use a different color. So step number 3, then you look on the source and destination and make sure that telnet service is functional. Like router 1 could send outbound telnet connections, and router 4 can accept those inbound telnet connections. So telnet works on endpoints, so it's not being filtered by any kind of configuration. And step number 4, you look in the transit path for any kind of filters, layer 2, layer 3 filters in transit path. So clearly it makes more sense to even start like it that way. So first make sure routing works, then make sure that basically the ASAs, for example, are going to be properly configured. Identify what's configured in the ASA. We're going to see how fast you can actually do that on the ASA with packet trace, for example, which is a useful tool. So after you make sure that the ASAs, both of them, allow the traffic to pass back and forward, then if it doesn't work, so after the first 2 steps, you're going to try and telnet. If it doesn't work, then you're going to look in the transit path for any layer 2 or layer 3 filters to make sure that those are not dropping your packets. If those are, then you got to fix those around as well. And the thing is, you don't jump between those 4 steps, so you don't start with troubleshooting routing and then you change over to investigating the ASA's NAT. So you start with one step, then you finish it up, you make sure you fix that, the routing works, then you go to the next step, which is going to be the ASA, because on the ASA you can have a lot of things to broke your connection. You fix that up, then you go to then you try to initiate the session to see if it works. You do some more troubleshooting, like when we see in a couple of example, like if that session doesn't work. So we have made we went through steps 1, 2, okay, and then so we've made sure that steps 1, 2 are correct, and then we telnet between the devices, and it still doesn't work. So let's assume basically you initiate the telnet from router 1 through ASA 1. So you would initiate the telnet session from router 1, which is going to basically should go to router 4. So what do? You troubleshoot step by step, right? Because you have no idea currently. Maybe you didn't properly configure, you didn't properly verify the configurations on the SA, or maybe you did that and there are actually transit filters in the transit path. So because you don't know where those are, you're not going to go step by step on each device and see where the filtering is being done. Basically, you do, for example, what I would do, I would go on ASA 1 and show connection to see if ASA 1 received the packet, and if received it and it routed it out, it means the packet has went out of the SA. So if in the show connection you see the session state for that session, not only from the flags you're going to be able to identify if the SYN was sent, if SYN ACK was received as well, if ACK was sent, because looking at the flags you're going to know what is the session state. If it's TCP, of course. If it's UDP or ICMP, it's pretty much stateless. It is what it is. But for a TCP session, you have more information in there. And then, as I was saying, if you in show connection you see something in there, it means the packet has exited ASA 1. Then you go on the ASA 2 and say show connection as well. And then if you don't see any state in there, it means here there is a problem in between ASA 1 and ASA 2. So it can be in the transit path, a layer 2 filter, or it can be on the SA, a layer 3 filter, right? If you go on the ASA and you see something in the show connection, then it means the ASA 2 has routed the packet out to router 4. And basically that means that to make sure that router 4 receive the packet, if it's a TCP session, you're going to do like debug IP TCP transactions, real quick, debug IP TCP transactions to see receive the packet, if you reply or not. If it's ICMP, debug IP ICMP. If it's UDP, pretty much you're not going to do SLAs, so we can investigate that around. So this way we're going to know if the SYN or ICMP echo reaches router 4. Because if they do, it means that if the session doesn't work, there's a problem with the return traffic. Correct? And basically, if DSAs have allowed the traffic to go out, it pretty much means that DSAs are going to allow the traffic to go back in as well, because they statefully inspect the session, unless of course that session is not something which is not inspected, it cannot be inspected like ESP or GRE. So if router 4 replies, it means that the problem is not on DSAs. For sure, it means the problem is on this segment between router 4 and ASA 2, on this segment between the ASAs, or on this segment in here. Somebody somehow drops the reply traffic to be at that point. So this is how you gotta do troubleshooting step by step. Take your time, because otherwise, in the tissue tickets you're gonna get, they may be involved like 3-4 devices or 6 devices in line. So if you don't take a step-by-step approach to finish up something, oh, I fixed routing, it works, I fixed ASA, it works, I fixed whatever else we were speaking next, then if you could jump in between all of those, you're never ever gonna basically find what the problem is, because number one, there can be multiple problems, and number two, because you're jumping around from like troubleshooting routing to troubleshooting NAT to troubleshooting transit filtering, they never actually finish something up, and to make sure that, oh, I'm done with routing, it's good, I'm done with NAT, it's good. So the problem can be some other problem. Okay. There is a question, not exactly a question, from Kenisha. I thought the new CCIE exam would only ask the questions from version 3 and above. Well, I don't know exactly where you got that information, but if you look in the blueprint, and let's take a look real quick, on the ASAs, you get both the old platforms, which are going to be running code 8.2 or 8.4, and also the new ASAs, the X models, which are going to be running code 8.6. So you're going to be being tested basically on both the old code and the new code, at least in this version of the blueprint.